Hi everyone, we are group 34 and our capstone project is titled Glimpse. I'm going to quickly go over what we'll be covering in this video. We are going to start by outlining the problem we are aiming to solve, then discuss the solution we have developed and explain our project in more detail. Next, we'll go over how our application is designed, followed by a project demo. Finally, we'll conclude by discussing where we want to go from here and what we have planned for the future. Music and media play an essential role in our daily lives by positively influencing our mood, productivity, and concentration. In addition, taking photos to capture special moments has become a common practice for many individuals. Unfortunately, despite these two elements being heavily embedded in our daily lives, there is no direct way of incorporating music to enhance the memory of these special moments. And that is why we created Glimpse, a revolutionary mobile application that utilizes artificial intelligence, or AI, to identify the perfect song that matches the ambiance of a user-submitted photo. This innovative app can be used to enhance any experience that an individual wishes to remember and cherish, bringing more joy to life through the power of music. With Glimpse, users can easily find a song that fits the mood and tone of their special moment, making it easier to document and remember. This app allows individuals to enjoy their memories through listening to music on a music player application and sharing with others. Glimpse is the perfect tool to help you preserve and augment your most cherished experiences.
This is the high-level overview of how our application's main functionality works. As you can see, the front end written in Swift invokes an AWS Lambda function that performs a series of API calls to return a song based on the photo that the user has submitted, as well as gather and store the necessary information. When a user uploads a photo, the photo gets encoded into a base64 string to be sent over to the AWS Lambda function called GPT function using HTTP connection. Then, the GPT function sends the base64 string along with a unique file name and stores them in an Amazon S3 bucket. Then, the GPT function decodes the base64 string to turn it back into an image for the Amazon Recognition API to process and analyze it. Amazon Recognition API is a simple, easy-to-use API that can quickly analyze any image or video file that's stored in Amazon S3 provided by AWS. This process will return 3 tags that are considered the most significant in the image to be used in the next step. Initially, we planned on building and developing our own machine learning algorithm to find a song based on the tags from the photo. However, with the emerging AI technologies that have been actively developing, we decided to make use of the leader amongst them, the TextDaVinci 003 model by OpenAI. This is the same model that powers the well-known ChatGPT. We implemented the OpenAI API and we send the following prompt. Give an existing song name and singer based on these keywords, tag 1, tag 2, and tag 3. I would like it to be in one of the following genres, a list of genres. It doesn't have to include the keywords in the song, lyrics, or title. It just has to have some correlation. Make sure that the song is both available on Spotify and Apple Music. Give me a different one than your previous answer. Give me an answer in the following format and no other explanations. Song name, singer, genre, and then a unique message ID. The model then returns a song in the format shown on the slide to be displayed to the user. It also assigns a message UUID that will be remembered by the model. This is important for sending back to the model when giving feedback on whether or not a recommendation was good or not.
After the song recommendation is returned, we call the Spotify API to obtain a song link that will allow the user to be directed to the selected song in the Spotify app. This is the last step that occurs in the GPT function. After this process, this Lambda function returns the following: the file name that was assigned to the uploaded image, the title and artist of the song chosen, and the corresponding Spotify song link and song ID. Some of these values are used to send to another Lambda function called addHistoryItem, which will be discussed in the next slide. There are 3 other active Lambda functions in this application. The first 2 are very intuitive. All users of Glimpse can choose to create an account and log in to use the application. When they do sign up, their chosen username, email, and password get sent to the Create Account Lambda function, and the values get stored in a relational database along with a Universal Unique Identifier, or UUID, for the user. When they log in, their inputs get sent and checked with the database, and if everything matches, they are able to log in. If the user chose to rate the song that Glimpse recommended based on their photo, meaning they either clicked like or dislike. The data of the image, the song information, the rating, and the message UUID for the song recommendation get sent to the add history item Lambda function. When an item is added to the history table within the function, the model is given feedback on whether it gave a good response or not. This allows it to learn for future recommendations.
When opening the app, the user is initially greeted with the home screen where they have the option of taking a photo or uploading a photo from their photo gallery. By clicking on the button located in the top right corner, we can access the settings page where we can either sign up for a new account or log in. If the user chooses to log in, their data will be stored in their account. If you're a new user, you can register an account by selecting a unique username, password, and email. In case the email or username is already taken, the user will receive a prompt. It is important to ensure that the chosen username and password meet the specified requirements. Otherwise, the user will receive a notification regarding the requirements. Once the account is created and approved, the user will be taken to the sign-in screen. If the username or password do not match the system, the user will be prompted with a message that their username or password is incorrect. If it matches an account in the system, the user will be taken back to the home screen. Now, we will begin the main demo by taking a new photo. The user will be prompted with the camera application where they can take their photo. When clicking Use Photo, the user will be prompted with a message if they want to use that selected photo or not. Otherwise, they can choose a different photo by clicking on the button Take Photo or Upload Photo. This time, we will choose to select an image from their photo gallery. Once the user decides on a photo to use, they can continue with the button I'm ready. The application will pull up a loading screen as the information from the image is being processed. Upon completion, the user will be directed to the song preview screen where they can preview their submitted image alongside the song title and artist information. The user has the option to listen to the song using Spotify or Apple Music, which is coming soon. They can also indicate whether they like or dislike the song, which will be saved to their account. The image, song title, artist, and link can be shared via social media.
Despite our application being fully functional, we have discussed some upcoming implementations. This includes the Apple Music integration for those of you who use Apple Music, having the ability to share the photo and the song on Instagram as a story, and eventually deploying the application onto the App Store. We've already gotten started on the 2 other upcoming implementations we have planned. In the Add History Item Lambda function discussed earlier, we are already creating a table for each signed up user and adding their uploaded images and return songs into the table if the user chooses to give it a rating. We currently do have a Lambda function that fetches all the items in the table given the user's UUID. We will bring these to the front end soon. In terms of training the AI model in the GPT function, a message UUID gets created for each of the prompts and responses we get back from the model. We are planning on making this message UUID to be part of the request body when the Add History Item Lambda function is invoked. Then, with the rating from the user, the model will be able to learn which responses satisfied the user and which did not. Overall, we had so much fun creating this project as it involved elements that we all like, such as taking photos and listening to music. We also really enjoyed this project because we had the opportunity to use the most popular and talked about technology nowadays. Thank you so much for watching our presentation video. We hope that you'll download Glimpse when it's available on the App Store.